To solve this problem, let's think about this block M as our system, and then we're going to draw a free body diagram for its center of mass. There's going to be some weight force down, mg, and there's going to be, from this surface, an interaction that is perpendicular and parallel. So the support of the surface is going to be perpendicular to the surface, and we'll call that normal to the surface. Then there's going to be some force of friction that essentially is going to happen parallel to the surface. Now, I'm saying that it's going to be up because it needs to be in whatever direction there is to oppose motion. That's what the question means when it says, is it necessary to keep the block on the wall? It has to balance this force. We could say that those things are going to add up to zero, so long as this isn't accelerating down or up. Okay, now we think about this external force that's being applied to the system that's pushing it into the wall. Let's add up all of our x component forces, and we see that there is that external force minus the normal force. And so long as we are keeping in mind that this is wondering how do we keep the block on the wall, then these two forces need to add up to zero. So that would mean that the external force is equal to the normal force. Now if I add up all the y forces, so sigma Fy, then we would have friction, let's say that that's positive, minus the weight will equal 0, because we also said that these two things are going to be balanced. And if it helps you visually, we can say that also for this situation, which then means that friction is just going to be equal to the weight of the object in order for it to not slip down the wall to begin accelerating.